So yeah, today we'll be covering these topics. Okay. So Dania requested that we can maybe spend more time on function and graph. Then Kunyang, do you have any topics here that you might see yourself having trouble with?
Angles, 5.
Okay, can angle triangles for you. Okay, so that okay, and also that will be quite related to congruence similarity. Okay, can then let's begin. Okay, so yes, join it. Okay, yeah, we'll just begin first. Okay, so let's begin. Okay, so functions and graphs. Okay, so our objectives. Okay, understand the concept of a function and how do you write a function. Okay, find the range of a function given a domain. Okay, so range is basically your y values and domain is your x values. Okay, then we will learn how to sketch linear and quadratic graphs. Okay, linear meaning it's like a straight line. Okay, and quadratic is your U shape or your inverse U shape. Okay, and then the key feature. Okay, the key feature basically for quadratic graph, right, will be your minimum point or your maximum point. Okay, and then finding the equation of a straight line. Okay, y equals to mx plus c. Okay, finding the gradient and the y-intercept. Okay, then lastly to determine the gradient and intercept of these functions. Okay, if you are like given it on a picture. Okay, so let's see what a function is. Okay, so a function, right, is this thing called a rule that assigns each input value one output value. Okay, so basically, it's like a machine. Okay, you put in like x equals to 3, then it spits out like x equals to 7, for example. Okay, then you spit out x equals to you put in x equals to 5, you spit out x equals to 11. Okay, so a function, right, you can never. One of the important things is you can never. If you put in x equals to 3, right, you can never get like two separate values. Okay? You put in x equals to 3, you get like one value only. You cannot get like x equals to plus minus. You cannot get like plus minus 3 as the output. Okay. So that's what a function is. Okay. So the output, right? Okay, the x is what you put inside the machine. Then the output, what the machine gives you back, is going to be called fx. Okay. Yeah. So the little thing, the little tip there is the little note is what you can kind of think of it as is a machine that you put in something, then you get something else. Okay, sorry. Okay, let's record that anyway. Okay, so let us see an example. Okay, so this notation, they give you fx. Okay, fx is basically a function that is in terms of x. Okay, then if I want to find f4, basically that's when I want to sub in x equals to 4. Okay, f minus 1 is when I want to sub x equals to minus 1. Okay, then for part C, fx equals to 20. So that means 3x plus 2 equals 20. Yeah, we solve the equation. Okay. So the first two are quite straightforward. You just sub in 3 times minus 1, 3 times 4 plus 2 is 14. And 3 times minus 1 plus 2 is minus 1. Okay. Then the last one is just solving a linear equation. 3x plus 2 is 20. Okay. Then not difficult to solve. X equals 6. Okay. Then another one. Okay. So this one is a bit more complicated. Okay, but okay, technically the quadratic function stuff is in the next chapter. Okay, but we'll have at least some idea of how to solve a quadratic equation, right? How to factorize it. Okay, so here, okay, g2 and g minus 3. Then lastly, find the value of x such that gx is 15. Okay, so the first one, g2. Okay, g2 basically is subbing 2 inside. Not difficult. Okay, but g minus 3. Okay, once again, the common mistake people don't do properly is to not use bracket. Is they don't use brackets. Okay, so minus 3 you need to use a bracket. Like when you square it, you need to put a bracket. Okay, in general, just always use a bracket when you substitute in stuff. Okay, because if you don't use a bracket, then the minus 3 squared you might see as minus 9 instead of 9. Okay, otherwise it's not difficult. Okay, then lastly part E is a quadratic equation. Right? Okay, so you quadratic equation how to solve, you make the right side 0. Then the left side, okay, two ways to do it usually. Okay, use a calculator to get your roots. Okay, or you use the crop method. Okay, then you guess and check the values. Okay, I think you all should be quite familiar with it. Okay, do a lot of quadratic equations and quadratic functions. Okay, so the answer is x equals to 5 or minus 2. And any questions on this? Okay. Yeah, then so give this question a try. 1.2.1. Okay, this one maybe about 3 to 4 minutes. 3 minutes. Okay. So this question there's a sort of quadratic equation for part B. Okay. Part A is just simply subing like that. Okay. So that one shouldn't be too difficult. Okay. So 3 squared is 9. Then you just summing 2 times 9 minus 5 times 3 plus 1. Okay. Answer is 4. Okay. So next one, find the values of x such that fx equals to f0. Okay, so we need to find out f0 is. So f0 basically means you sub in 0 inside. Okay, in this case it will just be 1. Okay, so your goal is to find 2x squared minus 5x plus 1 equals to 1. Okay, which means you minus 1 on both sides. It will be 2x squared minus 5x equals to 0. Okay, so here I think you can like kind of solve it already. Right? Okay, common mistake, okay, never go and cancel the x, okay, so both of these terms have x inside, but don't go and cancel it, okay, always factorize the x, so this will be x times 2x minus 5 equals to 0, okay, so here this means x equals to 0 or x equals to 5 over 2, okay, 2x minus 5 equals to 0, okay, so don't go and cancel the x, okay, always factorize if there are x in both terms, then that means x equals to 0 is one of the answers. Okay, and this one also I don't think will be too bad. I think yeah, I can give this one a try as well. for this pattern, right? The first two, okay, just simple. We have mark into just sub in 3 and 6. Okay. First one is 7, second one is 8. Okay. And but if find the positive value of x such that h is okay. So essentially you ask to solve 12 over x plus x equals to 8. Okay. So how to solve this, right? Okay, you cannot solve it in this particular way, right? Okay, when it's in this form. Okay, so what you have to do is to multiply x on both sides. And you get rid of the fraction. So that will become 12 plus x squared equals to 8x. Okay, then you can recognize this is a quadratic equation. Okay, so if you move everything over to the left side, it will be x squared minus 8x plus 12 equals to 0. Okay, so okay, then this guy you can factorize it. It's x minus 2, x minus 6 equals to 0. So x equals to 2 or 6. Okay. So they say find the positive value of x. Okay, so both are positive. Okay, so then that's great. Then there are two answers, 2 and 6. Okay. So if somehow you get one positive, one negative, then yeah, you will reject the negative answer. Okay, and any questions for this? Okay. Okay, then next we look at quadratic graph. Okay, this one is the most common type of function and graph that you see in EMath. Okay. Also like basically EMath also. But yeah. So what's a quadratic function? Okay, it's a function that has this form ax squared plus bx plus c. Okay, where your a is not 0. So it's called a parabola. Okay. And this a, right, which is called the coefficient of x squared, okay, coefficient meaning the number in front, this number here, okay, it tells you whether it is a U shape or inverse U shape. Okay, so if a is more than 0, okay, so for example, this blue color, the green color graph here, this is when a equals to 1, right, which is more than 0, so it will have a U shaped graph, and it has a minimum turning point. Okay, then the alternative, right, is when a is less than 0, then this will be inverse U, okay, upside down U. Okay, and has a maximum turning point. Okay, the maximum turning point is here. Okay, it's covered by this thing, but yeah, see, there's a minimum, there's a maximum. Okay, so how do you identify this? Okay, is to complete the square. Okay, complete the square. Yeah. So the key properties are as follows. Okay, so A10 is open outwards, the U shape, and minimum point. Okay, then the range. Okay, the range, right, means the y values that you can take. So for minimum point, okay, minimum point means this is the y value here is the minimum. Okay, that means every y value that you can take is everything that is above this guy, including him. Okay, so if the y value here is k, right? If it's k, then it's everything else above it, including this guy. Okay, so it's more than equals to k. Then for the inverse U shape one, okay, open downwards, okay, then it's a maximum point. And every point below the maximum value, okay, so the maximum value here say is k, okay, then every value below the maximum point, including it, is going to be a lot. Okay, so less than equal to k. Alright, so these are the extreme values. Okay, then how do we find this extreme value? Okay, given some random quadratic function, how do we find the value of this guy, or how to find the coordinates of this guy? Okay, is to complete the square. Okay, so you complete the square. Okay, you can get you can get sorry, the completed square form has this form. Okay, a times x minus h squared plus k. Okay. So your goal with any quadratic function, if you want to find this thing called the vertex, right? Okay, the vertex right can mean either minimum or maximum. Okay, this is called a vertex. Okay, to find the vertex, you need to complete the square. Okay, and then afterwards, if you compare with this form, if you compare with this form over here, then you can tell where exactly is the vertex. Okay, if you compare with this form, then if you identify the h and k, then really your vertex is h comma k. Okay. Yeah. So how do we complete this? Okay, I think the top part we can skip it. Okay, it is it has a reasoning why. Okay, but how do you actually complete a square? Okay, it's actually quite simple. So your first goal actually is to check whether the number in front of x squared is 1. Okay, if it is not 1, you have to go and factorize some numbers. Okay, so here the number in front of x squared is 1. Okay, so that's good. We don't have to go and factorize it. Okay, then next we look at the number in front of x. So here is 6. Okay, so 6. Okay, this number 6, right? What you have to do is to divide by 2. Okay, which is 3. Then you square it. That is 9. Okay, then you add 9 and then you subtract 9. Okay, so our original equation is this. Okay, then we have 9, right? Okay, add 9, subtract 9. Okay, then the thing that you add, right, the 9 that you add, it should help you to complete the square for the first 3 terms. Okay, then afterwards, all you do is to simplify the outside. Okay, then if we compare with the form earlier, which says this, okay, a times x minus h whole thing squared plus k. If you compare with this form, okay, you can see that the h is actually minus 3 and then the k equals to minus 4. Okay, so the minimum point is minus 4. Okay, so once again, why is this minimum? It's because the coefficient of x squared is positive. Okay, the number in front of x squared is positive, so it's a U-shaped graph. So it's a minimum point. Okay, and the minimum point has minus 3, minus 4 as the coordinates. Okay, any questions about this? Okay, you heard this before in the EMath video, right? Yeah, everything in this again. Okay, yeah, so, okay, then now the next example, what happens if you do not have 1 in front of the x squared? Okay, if you don't have 1 in front of x squared, okay, so here is 1, but here is 2. Okay, so if it's any number that's not 1 in front of x squared, then you have to factorize the number in front of x squared. Okay, so here is 2. So you have to factorize 2 from x squared and x, the 2 terms. Okay, you have to factorize 2. Okay, then now we do the same thing. Once you factorize it, you do the same thing. Okay, so you look at this minus 4. Minus 4, then you halve it, it's minus 2, right? Then you square, it's 4 again. Okay, then you add 4, you minus 4. Okay, but take note to do it inside the bracket. Okay, so here you plus 4, minus 4. Okay, don't plus 4, minus 4 outside the bracket. Okay, the bracket is here. So do it inside the bracket. Okay, so you plus 4, minus 4, then this guy here becomes x minus 2 whole thing squared. Okay. Then afterwards, then you simplify, right? This 2 will multiply with this minus 4, which becomes minus 8. Then minus 8 plus 7 is minus 1. Okay. Then compare with the form, okay, a times x minus h squared plus k. Okay, then the h here is 2 and then the k is minus 1. Okay, so the vertex is 2 comma minus 1. Okay, and then whether this is a minimum or maximum point, okay, you look at the number in front here. So here is 2. Okay, so 2 is more than 0, so it's maximum or minimum. Okay, then we look at one last example. Okay, this one is when there is a unknown, sorry, not unknown, there's a negative value in front of negative coefficient. Okay, so if it's negative means it's a maximum point. Okay, then we can do the same thing. Okay, if it's not, if the coefficient is not 1, then you have to factorize. Okay, so you factorize the x squared and x term. Then notice the plus here becomes a minus. Okay. Then this value here, minus 4, okay, you half it, which is minus 2, then you square it is 4. Then you plus 4 minus 4, okay, same steps. Then this guy here becomes x minus 2 squared. Then minus times minus 4 will be plus 4. And then plus 4 plus 1 is plus 5. Then you compare with the form again. The h is minus 2 and the k is 5. Oh, sorry, the h is 2 and then the k is 5. Okay. So this is 2 comma 5. The vertex is 2 comma 5. And then whether it's a maximum point? Okay, it is because negative in front. Okay, okay, yeah, you can try this question first. Okay, completing a square. Okay, yeah, I think this one 1.2.3. I think okay, A and C, A and C, A and C. Maybe about 4 minutes. Okay, look at these examples. Okay, so the first one, okay, the number in front of x squared is 1, so you don't need to go and factorize. Okay, then what we do is we take 4, we divide by 2 is 2, and then 2 you square it is 4. Okay, so you plus 4 minus 4. Okay, so x squared plus 4x. This thing is equal to x squared plus 4x plus 4 minus 4 minus 3. Okay. Then these three guys will always, the first three terms will always form the so-called completed square. Okay, this one you can recognize as x plus 2 squared. Okay, then minus 4 minus 3 is going to be minus 7. Okay, so x plus 2 squared minus 7. Okay, so the vertex here is going to be, if you compare with the form earlier, the vertex is going to be minus 2 comma minus 7. Okay, because it's minus or minus 2. Okay, and then the coefficient is of x squared is positive, okay, is 1. So this is a minimum point. Okay, or a U-shaped graph. Okay, then the next one, okay, for C, right? For C, the number in front of x squared is negative. It is not 1. Okay, so we should factorize it. Okay, and also notice that the number in front is negative. Okay, so it's going to be a maximum point. You can take note of that for later. Okay, so our first step is to always factorize the x squared and the x term. So minus 3 x squared minus 2x plus 2. Okay. Then what do we do now? Okay, the minus 2 we can half it. Okay, it's minus 1, then square is 1. Okay, so inside the bracket we plus 1 and minus 1. Okay. So inside the bracket minus 3 x squared minus 2x plus 1 minus 1. Okay, then outside is still plus 2. Okay. Then these three guys here will actually, these three guys here will form a completed square again. This one will be x minus 1 squared. Okay, so it's minus 3 times x minus 1 squared. Okay, then we can simplify a bit. This minus 3 times this minus 1, right, will be plus 3. Okay, then afterwards there's still a plus 2 outside. So plus 3 plus 2 minus 3 x minus 1 squared plus 5. Okay, so the vertex here will be 1 comma 5, and then this one will be a maximum point. Okay, a maximum value. Okay, so just take note. Okay, this guy here will be the completed square, so will be x minus 1 squared. Okay, then this minus 3 will multiply by minus 1. You get plus 3. Okay, then the plus 2 will just remain outside the whole time. Then you just combine with the number inside afterwards, after you expand it. Okay. And any questions about this? Okay. It's very important because later you see the next part is about sketching. So if you don't know if you cannot find the turning point, then it's very hard to sketch graphs. Okay. Not possible. Okay, so we just did some practice involving the how to find the turning point. Okay, so to sketch a graph, okay, to sketch a graph is actually not so difficult. Once you know the turning point, you're basically done with most of the work. Okay, so how to sketch a quadratic function? Okay, the first thing you should do is the one that's very easy to tell is whether it's a U shape or inverse U. Okay, and to tell that, look at the coefficient of x squared, more than 0 or less than 0. Okay, then you complete the square to find the vertex. Okay, then of course when you draw any graph, you should try and find the y-intercept and the x-intercept if they have any. Okay, then you plot a point. Then you just connect the dots. Basically, so imagine if you have a graph like this. Okay, then I found a turning point to be, let's say, here. Okay, then there's an x-intercept here and x-intercept here. Okay, once you have these 3 points already, right, and then you know it's a U-shaped graph, you can easily just connect the dots. You just draw something like this. Okay, it's quite simple. Okay, I guess you can. This one also need to find. Okay, so few things you need to find. Okay, vertex, x-intercept, y-intercept. Okay, once you have those, you just draw a quadratic graph, U-shape or inverse U-shape through all of these points. Then you can get the answer. Okay, so the completion square part I won't really mention too much at this point. Okay, you can't really know the process of it. Okay. So here, okay, you're asked to find the turning point of this function. Okay, so you complete the square, then you compare with the form, you see the vertex is 2 comma minus 1. Okay, and then you're asked to find the coordinates where the graph crosses the axis. Okay, so we need to find the x-intercept and the y-intercept. Okay, so x-intercept is when y is 0 and y-intercept is x equals 0. Okay, so the y-intercept will be y equals to 3, and then x-intercept will be 1 and 3. Okay, so we found the three important details already: the x-intercept, y-intercept, and then the turning point. Okay, then you can draw that. Okay, so once you find these three things, right, you plot it on the graph, then you just connect the dots. Okay, it's that simple. Okay, then another example. Okay, here this one you can see it's going to be a negative. It's going to be an inverse U shape. Okay, and it just so happens that this graph they give you in the computed square form. Okay, so the vertex here is 1 comma 4, which is a maximum point. Okay, so your only goal now is to find the x and y intercepts. Okay, x intercept is 3 and minus 1, and then y intercept is just 3. Okay, then you plot those 4 points and you just connect them. Okay, okay, then the last example we'll see for this. Okay, so we are given the equation of this curve and then find the turning point, coordinates of the turning point. Okay, so the turning point here is minus 1 comma 4. Okay, good. Now we want to check for x intercept. Okay, so actually this curve, right, the special thing is there is no x-intercept. Okay, there is no x-intercept. Okay, is that y-intercept? Okay, there is a y-intercept at y equals to 5. Okay, so if there is no x-intercept, means you can expect the graph to be above the x-axis. Okay, like this. Okay, so really this part of the topic about sketching graphs, I think it's, once you can complete the square, you can find x and y-intercept, then you're basically done already. Okay, any questions? Okay. Yeah, I think 1.2.4 hours. Okay, 1.2.4 hours should answer. Okay, so essentially what you need to do here, okay, is to completing a square. Okay, that one I want to go through that. Okay, so completing a square will allow you to find. Okay, if it is a U-shaped graph, you find the minimum value. Okay, the minimum value is the y coordinate of the minimum point. Okay, the minimum value is the y coordinate of the minimum point. Okay, so if it's a U-shaped graph, right? Okay, then say the minimum point here is k. Okay, that means it can take more than equals to k. Like the range, right, means all these y values here will be more than equals to k. Okay, so if your minimum value is 1, then this range, right, which is your basically asking what y values can the graph take be more than equals to 1. Okay, so this one is quite simple. Okay, the 1.2.5 also is just a computing square fraction. Okay, you can give 1.2.6 a try. Okay, this one is a bit different from a typical style, okay, but if you understand the topic now, it will be too difficult to go to solve. look at this question now. Okay, so they give you this one. They give you a sketch of the graph. Okay, then you ask to find firstly the values of B and C. This part of the equation. Okay, then complete the square and find the correct turning point. Okay, so your goal is to really find once you find the values of B and C, then the rest is not difficult already. Okay, so notice okay, the easiest way to do this, right, is notice that the roots are -2 and 4. Okay, so in other words, this graph you can write it as x plus 2, x minus 4. Okay, so x minus 2, x plus 2, x minus 4, if you expand it, this will be x squared minus 2x minus 8. Okay, then if you compare with the original graph, okay, this means b is, okay, if you compare, this means b is -2 and c is -8. Okay, so you can quite easily compare it with the equation. Okay. Another way you could possibly do it is to substitute these values inside. Okay. But yeah, I think this way is probably easier. Okay. Then I don't think you'll have much issue completing a square. Okay. Once if you have this equation, then completing a square is not difficult. Okay. This will be the completed square form. Okay. Then the coordinates of the turning point will be 1 comma -9. Okay, which will agree with this picture. Okay. You can kind of see from this picture that it will be 1 comma -9. Okay. Any questions about this? Okay. Then yeah, the next portion we already kind of covered, right? The range of values is basically the y values that the function can take. Okay. And then for a quadratic function, you just complete the square so you can get these values. Okay. So for U shape the minimum value is k, so the range is everything above k including it. If it's inverse U, then it's everything below k including k. Okay. So this example, okay, is basically what I've seen before already. Given a function, complete the square, okay, complete the square already, then the minimum value will be the y coordinate of the turning point, so it's 3. Okay, and that happens when x equals 2. So your range is basically more than equals to 3. Okay. Uh, yeah, okay, the next example, I think we'll skip it. Okay. Let's see. Okay, then you can give 1.2.7 a try. Okay. It's not too difficult, it's basically something else. Let's look at this one real quick. Okay, so this one pretty standard, right? Complete a square not difficult. Okay, just remember to factorize this. Okay, so I'll do it real quick. Minus sign x minus x squared minus 6x plus minus 5. Then you divide minus 6 by 2, which is minus 3, and square it, it's 9. So x squared minus 6x plus 9 minus 9 minus 5. Okay, and this guy is basically x minus 3 squared. Then minus and minus 9 will become a plus 9 minus 5, okay, which becomes minus x minus 3 squared plus 4. Okay, so we have expressed it in this form already. Okay, then the minimum value, okay, okay, first of all, the vertex will be 3, 4. Okay. So in this case, right, the maximum value, because maximum is because of this minus sign here, the maximum value will be the y coordinate of this. So maximum value will be 4. Okay, and thus the range will be everything that is everything that's below this, including it. So less than equal to 4. Okay. Yeah, the next one we'll see. Okay. Then we talk about linear graphs. Okay, so linear graphs is basically a straight line. Okay, the straight line you have two forms. Okay, first one is the gradient intercept form, the y equals mx plus c. Why is it so blur here? Screen. Okay. Was it always blurry at that? Okay, let me try and stop sharing screen and share it. Okay, but I zoom in, I think it's a bit better. I don't know why on my screen is like not so blur. Yesterday was it blur? Yeah, I'll try to figure it out later when you're doing work. Okay. So equation of a straight line can be written in two forms. Okay, gradient intercept y equals mx plus c. Then the other one is y minus y1 equals to mx minus x1. Okay, so basically you need to know a point on the graph or on the straight line. Okay, and then you also need a gradient. Okay, the gradient is rise over run. Okay, in other words, it's y2 minus y1 over x2 minus x1. Okay. So rise over run, rise is the increase in x coordinate, y coordinate, and run is the change in the x coordinate. Okay. So finding the equation of a line. Okay, finding the equation of a line. For part A, okay, you have the gradient, you have a point that it passes through. So in this case, yeah, honestly you can use either one, but in this case they chose a point gradient form. Okay, point gradient form, what do you need? You need a gradient and then you need a point on the line. Okay. So you sub it in, so the gradient is 3, y minus y1 equals to m times x minus x1. Okay, so x1 is 2 and y1 is 5 in this case. Okay, then you move everything around, then y equals to 3x minus 1 is the answer. Okay, then for part B, you don't have the gradient, so you have to calculate the gradient. Okay, so the gradient in this case, we pick this to be the second point, we pick this to be the first point. Okay, then the change in y coordinate is 9 minus 3, which is 6, and then the x coordinate is 4 minus 1, which is 3. Then the gradient is 2. Okay, then once again we're using the y minus y1 equals to m times x minus x1. Okay, the m in this case is going to be 2. Okay, then you substitute in 1, 3 inside the equation. Then you make y the subject. Make y the subject. Okay, then this is the last example here. Okay, so this line has equation 3x plus 2y equals to 12. Okay, find the gradient of L. Okay, to find the gradient, you need to write it in y equals to mx plus c. Then if you write it like this, then the gradient is the number in front of x. Okay, but in this form you cannot tell. So our goal is to write to make y the subject. Okay, so once you make y the subject, right? This will be what happens when you make y the subject. Okay, then clearly you can see that the gradient will be minus 3 over 2. Okay. Then for part B, find the coordinates of the x-intercept and y-intercept. Okay, so this one, as per usual, you can solve it. X-intercept is when x is y is 0 and x-intercept is when y is 0. So solving it, x-intercept is 4 and y-intercept is 6. Okay, so it's fairly standard stuff. Okay, then part B, sketch L, reviewing both intercepts clearly. Okay, so actually straight line is the easiest to sketch. Okay, why is it easy to sketch? you have 2 points, okay, y-intercept, x-intercept, then you just draw a line that goes through both. Okay, that's all. Quadratic, then you still need to do draw at 4 points. Okay, any questions about straight lines? Okay, then we can look at this one, maybe about 4 minutes. That was a problem. Okay, let's continue. Okay. Okay, for this question, share screen. Okay, for this question, right? Okay, we need to find a first we need to find a gradient, right? So the gradient is if we pick this to be the second point, this will be the first point. Okay. Gradient is rise over run. Okay, y2 minus y1 over x2 minus x1. Okay. So the y2 here which we choose to be 7, and the y1 here will be minus 1. Okay. Then the x2 here is 5, and then the x1 here will be 1. Okay. So this is 8 over 4, which is 2. Okay, so our gradient is 2. Okay, so your gradient will be positive. If you just to verify your gradient is positive if your x increase or y increases. Okay, then equation of line AB. Okay, we can use the point intercept form. Okay, which is y minus y1 equals to m times x minus x1. Okay, so in this case, we use one comma minus one as our x1 y1. Okay, so y minus y minus y1 which is y plus 1 equals to 2 times x minus x1, so it's minus 1. Okay, so it's y plus 1 equals to 2x minus 2, which means y equals to 2x minus 3. Okay, then part C, okay, AB cuts the x-axis at point C, y-axis at point C. So somewhere here, okay, somewhere down here, you extend the line more. Okay, so at C, x equals to 0. Okay, at y-intercept x equals to 0, right? So y equals to minus 3. Okay, so okay, and then lastly they ask for coordinates. So coordinates of C will be 0 comma minus 3. Okay, any questions about it? Okay. Okay, then yeah, I think we have a final break. Okay, we come back at 4. I'm gonna fix this thing. Okay, we continue on with this. Okay, so last portion of this chapter, okay, gradient of a curve at a point. Okay. So okay, usually these questions will come when like I think sometimes you see the sketching questions, right? Those like curve sketching questions. So you'll be asked to sketch a tangent, a gradient of you have to find a gradient of a curve, okay, at a point. Okay. So in EMath you can't really like without sketching a gradient you can't do that. But EMath you can differentiate, find a gradient at any point. Okay. But for EMath, what you have to do is if you want to find a gradient at a particular point on a curve, for example like this. Okay, if you want to find a gradient here, what you must do is to draw a tangent. The tangent means it's a line that touches at one point exactly. Okay, so a tangent is like this. Okay, then you find the coordinates of these 2 points and then you calculate the gradient. Okay, then the gradient is approximately the gradient at this point. Okay, okay. So the gradient of a curve at a point, right, is the gradient of a tangent drawn to the curve at this particular point. Okay. Then, as mentioned yesterday, right, gradient for distance time graph, okay, the gradient is speed. Okay, and for speed time graph, the gradient is acceleration. Okay. So yeah, our step, okay, as mentioned, right, you draw a tangent at the point, and then you choose 2 points in the tangent. Okay. So don't choose too close like this. Don't choose too close like this. Okay. Choose a bit further away. Okay, further away. So then the overall pattern will be better. Okay, then you calculate your gradient. Okay, so use a longer tangent line. Okay, the further they are apart, the better. The 2 points. Okay, so this question here, okay, particles distance time curve has a tangent at t equals to 5, passing through 310 and 730. Find the speed at t equals to 5. Okay, so in here, right, okay, just notice that the gradient for distance time graph is a speed. Okay, so essentially you want to find the gradient at t equals to 5. Okay, so you just find the gradient using these 2 points is 5 meters per second in the speed. Okay, so this is like more on context of like physics question. Okay, the next one, the tangent to y equals to x squared plus 1 and x equals to 2 passes through 0, -3 and 4, 13. Find the gradient. Okay, so once again, this one is not difficult, right? You have the 2 points already, you can just easily find the gradient. Okay, 4. Okay, I mean, here I never give any sketching because it'll take too long, but like in EMath exams, there will be no sketching, then they'll ask you to calculate the gradient at a point, then you just do this step of drawing a line that touches this point exactly once. Then you choose 2 points that are sufficiently far apart. Okay, here we can do part A and B. Okay, it will take about 3 minutes. I'm not sure I see very. Okay, never mind. If I zoom in, it's not so bad, but it's like zoomed out, it's like very terrible for some reason. Not sure why also. Give it a second, it's taking its own sweet time. Okay, so A and B, okay, so tangent at point A passes through -1, 2, and 3, 10. Okay, so the gradient here will be, okay, this is the letter M. Okay, M equals to, okay, if we choose the second point, so 10 minus 2 over 3 minus 1. So 8 over 4, which is 2. Okay, answer is 2. And okay, part B, they say all this stuff, okay, but essentially what we need to do is just find the gradient. Okay, so the gradient here, we use the second point, 30 minus 10 over 7 minus 3. Okay, so 20 over 4, which is 5. Okay, in this case, because it's speed, then you write units meters per second. Okay, the other one also, I mean, the last one, if you take a look at it, it's also the same idea. Okay, it's essentially just the gradient. Okay, so okay, here, this chapter is what we've done. Okay, function notation. For some input, you get output. Okay, domain is your allowed inputs and your range is output. Okay, then your graph. Okay, EMath you really learn about two main graphs. Okay, the quadratic graph and a straight line. Okay, and how to find a gradient. Okay, a gradient is for a curve you draw a tangent at a point, then you calculate the gradient of the tangent. Okay, and for distance time graph, the gradient is speed, and for speed time graph, the gradient is acceleration. Okay. Any questions? Okay. And next we go to equation and inequalities. Okay, so this one, I think is quite one of the more fundamental chapters. Is like the steps to solve is very quite similar. Across both questions. Okay, so I'll go here. Solve quadratic equations by factorization, formula, and computing the square. Solve fractional equations and solve simultaneous equations. Okay. So yesterday's the last topic, right? Okay, is expressions. Okay, expression means there's no equal to sign. Okay, equation means have. Okay, so quadratic equation, okay, is quite familiar. It's just form ax squared plus bx plus c. Okay, now it's equal to 0. Okay, earlier is the function, right, is y equals to ax squared plus bx plus c. Okay, this one is equal to 0. Okay, so there are a few ways to solve it. Okay, typically you would only use the first two methods. Okay, you use the first two methods. The last one only if it's convenient, then you can use it. I won't suggest computing the square. You don't need to because it's more effort. Okay, usually you can solve using the first method. Okay, then if the answer, okay, if you use a calculator to check the quadratic equation, right, if the answer is not very nice, then you probably have to use the second one. Okay. Okay, so the cross method, okay, I think you all should be familiar. Okay, these are the steps. Okay, it is like someone who like never do before. This is what they would read. Okay, I think you all have an idea of how to do a cross method. Right. Okay. Then this part I'll just skip it. Okay. We see an example. Okay. So you really just want to guess and check values. Okay. So factorize 3x squared minus 5x minus 2. Okay. So of course for the x squared, right, the 3x squared, one of them will be 3x, one of them will be x. Okay. So we want this is 3x squared. Then we want minus 2, right? So minus 2, okay, we have a few choices. In the end it happens that plus 1 and minus 2 happen to be a good one. Okay. Yeah, you can only really choose for minus 2, right? You can either choose plus 1 minus 2 or minus 2 plus 1. Okay, two choices. Then the correct choice is plus 1 and minus 2. Okay, so your roots are 3x plus 1 and x minus 2. Okay, this one shouldn't have any issue, right? Okay. Then other factorization question. Okay, I'll go through like maybe like A and B, how I will do it. Okay, so we want x squared plus 5x plus 6. Okay, so plus 5x. Okay, so here must be plus 6, right? Okay, then plus 5x. Okay, so I think it should be quite obvious. This should be plus 2 and plus 3. Okay, then you cross multiply this is plus 2x plus 3x. Then this is plus 5x. Okay, then good. Then maybe for part C, okay, part C we have 2x squared, right? Okay, then this is plus 3. Okay, then you want plus 7x. Okay, then it should be quite obvious also that this should be plus 3 and plus 1. Okay, then this is plus x, this is plus 6x. Okay, you can see that it agrees with the answer factorizing. Then this x is minus half or x equals to minus 3. Okay, and any questions for this? Okay, if not, then okay, this one A and C. About 3 minutes. Want to you want to do the want to do EMath and this chapter for like very easy. Later then in this module then there are the chapters that EMath don't really cover too much, like set language notation and matrices all this. Yeah, this so after this one then it's equation inequalities, then yeah after the next chapter is set language notation. Okay. Okay, so okay, we'll look at this one real quick. Okay. So for A, okay, I think this one is x plus 3, x plus 5. You can see it's plus 15 x squared. There's plus 3x plus 5x. Okay, so it's plus 8x. Okay. So x is minus 3 and minus 5. X plus 3, x plus 5 equals 0. Okay. Then for part C, okay, this one is 3x 3x squared plus 3. Okay, here is plus 3 plus 1. Okay, plus 9x plus x. Okay. So 3x plus 1, x plus 3. Okay, then it will be minus 1/3 or minus 3. Okay, any questions? Okay, this one still be very straightforward. Okay, and quadratic formula is used when you cannot easily find a root, or you cannot easily use the cross method, or you cannot use the cross method. Okay, so how to if you see an equation, right? What I suggest to do first is you key in your calculator. You ask the calculator to solve it first. If your calculator gives you a nice answer, then you write the cross method working. Otherwise, use the quadratic formula. Okay. Of course, you can always use the quadratic formula even if you have a nice answer, but it's a waste of working, right? If you do that, it's too much working. Okay. So for example, this question actually you can solve using the cross method, but then if you use quadratic formula, it still works. It's just that it's a bit more troublesome. Okay. Yeah, and this formula you should memorize it also. Okay, it's not given in the formula sheet. Okay. Okay, for this one, let's do part A. Actually, part B. Yeah. Do part B. Okay. Okay, for part B, this one actually can solve using quadratic formula. Okay. Sorry, the cross method, but this is just a practice for the equation. It's hyper-execution. Yeah. Okay. I'll share screen. Okay. So for this one, for part B, x equals to minus b plus minus square root of b squared 2 squared minus 4 times 3 times minus 1. Okay. Over 2 times 3. Okay. So it's minus 2 plus minus square root of So 4 plus 12, okay, to simplify, 16 over 6, okay, and square root 16 is 4, so 2 plus minus 4 over 6, okay, so it's either, okay, minus 6 over 6 or 2 over 6, okay, so it's minus 1 or 1/3, okay. So okay, usually when you use the formula is when you don't have a nice answer like sets, but of course you can use it when it's nice. Okay, but typically you will try to use the cross one, then you cannot, then you use then you use this formula. Okay. Then let's start the computing square. Yeah, we just cover already. So this one let's already speed through it. Okay, but you can use it the computing square to solve an equation. Okay. So here we just look at part B. Okay, for part B, okay, first we complete the square. Okay, so once you complete the square, right, you see that okay, you have x plus 3 squared minus 7, okay, minus 9 plus 2 is 7. Then you move the 7 over. Okay, then what you can do is to square root both sides. Okay, square root both sides. Okay, but then you need a plus minus here. Okay, then afterwards you minus 3 on both sides. So minus 3 plus minus square root 7. Okay, so this is yet another method you can use, but then I guess it's only when you complete the square already then you use it. Okay, otherwise just use one of the first two methods. Okay. Okay, complete the square practice we have done already. Then okay, I try part C. Okay. Solve this by completing the square. Okay, this one real quick. Okay, this one not difficult as well. Complete the square should be x minus 2 squared minus 5 equals 0. So x minus 2 squared is 5. Okay, so x minus 2, okay, you square root both sides, it will be plus minus square root 5. Okay, then you add 2 on both sides, this x is 2 plus minus square root 5. Okay, that's the answer. Okay, any questions? Okay, and this one is pretty common in EMath, okay, fractional equations. Okay, we kind of explore how to deal with it in the expression chapter, okay, because essentially, right, equation is just expression, just that the right hand side is equal to something else, right? Okay, so fractional equation, how to combine them together, okay, we kind of looked at it yesterday already, so this one I won't spend too much time on it as well. Okay, fractional equation, you want to combine them together by making the denominator the LCM. Okay, so for part A, okay, you want to combine these two fractions. Okay, the LCM will be x times x plus 1. Okay, typically the LCM is just the LCM is just going to be one of the denominator times the other one. Okay, so you combine them, then this one will be 3 times x plus 1 plus 2 times x. Okay, so there are two ways to do it. Okay, the first way is to multiply both sides by the LCM. Second way is to combine first. Okay, so the working that I've written here, right, is by combining, it is by multiplying throughout. Okay, you can also go and combine them. Okay, So I'll show you what to do if you want to combine them first. Okay, combining first it works as well. Okay, so to combine the fractions, it will be like this: 3 times x plus 1 plus 2x over x times x plus 1 equals to 1. Okay, then you multiply x times x plus 1, okay, so 3x. Then here will be 5x plus 3 equals to x times x plus 1. Okay, so x squared plus x equals to 5x plus 3. So x squared minus 4x minus 3 equals to 0. Okay. So two methods. Okay, the first method is to multiply both sides by the LCM. Second one is to combine the fraction first. Then you multiply both sides by this, which is the LCM also. Okay. You will see that both of these are the same equation. Then you have to solve it. In this case, you need to use the quadratic formula. Okay. Then for part B, okay, for part B actually it's much simpler. For part B you can just cross multiply. Okay, cross multiply and then you solve the equation. It's minus 11 over 2. Okay, any questions? Okay. So these are the typical methods to solve this sort of fractional equation. Okay. Um okay. Give this this one let's do part A. Settle it. Okay. So for part A, okay, choose either approach to combine the fraction first and multiply, or you can multiply throughout by the LCM. Okay. So maybe I'll do the other approach of multiplying by the LCM. Okay, so LCM is going to be x times x plus 2. Okay, the two denominators will multiply together. Okay. So yeah, first we always want to try and get rid of fractions eventually. Do it first, can do it later, doesn't matter. Okay. So LCM is going to be x times x plus 2. Okay, we multiply both sides by this. Okay, so we have 2 times x plus 2 because the x will cancel out for the first term. For the second term, the x plus 2 will cancel out, so this plus x equals to x times x plus 2. Okay, so 2x plus 4 plus x equals to x squared plus 2x. Okay, so x squared, okay, we simplify more, so 3x plus 4 equals to x squared plus 2x. Okay, then we move everything to the right side. X squared minus x minus 4 equals to 0. Okay, I think this guy you use the quadratic formula. The quadratic formula, once you use it, you should get 1 plus minus square root 17 over 2. Okay, yeah. So these equations are a bit more troublesome to solve. Okay, for part B, then it's very simple. I can just see it's cross multiply and solve it. Okay, for part A, these are the more difficult types of fractional equations that can come up. Okay. Okay, then next simultaneous equation. So simultaneous equations is usually two equations that have two unknowns, okay, x and y. Okay. So simultaneous equations in EMath we usually use the elimination method. Okay. So how to use the elimination method, right? We make one of the coefficients the same. Okay, so the number in front of x or y, you make it the same in both equations. Then you add or subtract. Okay, your goal is to remove, is to so-called eliminate the variable to remove it. Okay, then you solve for the other variable, and then you sub it back in to find what the variable is, what the value of the variable is. Okay. So quick examples. Okay, 2x plus 3y is 13 and 3x minus 2y is 0. Okay, so our goal here, okay, what we might try and do is to eliminate y. Okay, so how to eliminate y? Okay, maybe I want to make y for the first equation. I want y to be 6, and then this one I want it to be minus 6. Then if I add the two equations, then the y's will disappear. Okay, so if I multiply the first equation by 2, I get 4x plus 6y is 46. If I multiply the second equation by 3, then I get 9x minus 6y is 0. Okay, then if I add them together, then this 6y and minus 6y will cancel, right? Okay, so it's 13x equals to 26, which is x equals to 2. Okay, then x equals to 2, if you sub it back into either one of these equations, you get y equal to 3. Okay. Yeah, the second equation is essentially the same idea. Okay. Yeah, the second part is essentially the same idea. I won't really go through too much in detail. Okay. Okay, then what happens if you find the graphical, or if you find the solution to a pair of simultaneous equations? Okay. If you solve a pair of simultaneous equations, what you actually get is the you get the intersection point. Okay, if you have two straight lines and then you solve the simultaneous equations, the x and y value you get, right? So like for example, this pair of values, it will be the point of intersection. Okay, so that's just good to note. Okay, although you won't really be given like a picture in the exam. So. Okay, for this one, okay, this one just solve part A, simultaneous equation. Okay, one of the part that has a bit more algebra topics. Okay, for this one, right, if I call for part A, if I let the first equation be equation 1 and the second one be equation 2, then notice that I can get rid of y easily. If I multiply equation 2 by 2, then I'll have 4x minus 2y equals 14. Then if I were to add equation 1 and equation 3 here, then the 2y's will actually cancel, right? Okay. So if I add equation 1 and equation 3, I will have 3x plus 4x is 7x. 2y minus y is 0. Then 14 plus 14 is 28. Okay. This means that x equals to 4. Okay. Then I have x already, then I can find y. Okay. Then maybe I sub y equals to x equals to 4. Sub x equals to 4 into equation 2. Okay, so 2 times 4 minus y equals to 7. Okay, so 8 minus y equals to 7. So minus y equals to minus 1 and y equals to 1. Okay, so I mean you can do any other way to solve this equation as well. It doesn't really matter as long as you get the final answer. That's good enough. Okay, so besides elimination, right? You also can use this method called substitution. Okay, although substitution, usually you don't really need to use it too much, but it's still present, so you know how to use it. Okay. So if you are given this kind of equation, right? Okay, where you have one. Okay, so these are so-called uh linear equations, right? So linear meaning is a straight line. Okay. If it's non-linear, meaning is something like this, like a circle. Okay. EMath you don't really learn about circles, but if the equation is non-linear, then the only way to solve it is using substitution. Okay, so if this is equation 1, this is equation 2, then you're essentially subbing equation 1 into equation 2. Okay, so you substitute the linear equation. Okay, you have to make y the subject, okay, or x the subject first. Okay, the first step is to make y or x a subject, then you can substitute inside. If not, you cannot do anything here. Okay, so your first step, if this guy, right, is maybe like 2x plus y equals to 3, then you either make x or y the subject. Okay, you do that first. Then you substitute it inside the other equation, the other fellow. Okay, in this case, x squared plus y squared equals 13. Okay, so I plug in y equals x plus 1, then I simplify. Okay, you'll see it's a quadratic equation, which is x squared plus x minus 6, and the roots are minus 3 or 2. Okay, but if you solve x already, you're not done yet. You need to solve for y. Okay, so when x is minus 3, y is minus 2, and when x is 2, y is 3. Okay, so what does that look like when you draw it? Okay, so remember that if you the for two lines, right, the solution, right, is the point of intersection of two lines. Okay, and as you can see, this is the case for a circle and a line as well. Okay, let me see. This one, I think you can try part B. Okay. So part B, just to you do have to make for the linear equation, which is the first one, you need to make x or y the subject. It doesn't matter which one you choose. Yeah, that's it. Final answer. Yeah, sure. Yeah, if we understand the speed I'm going at is because like if any other student here also it's because they take EMath, then like I think most of the students that come here they don't take EMath also, they have to go a bit. So now this part I'll speak a bit faster. Okay. I think I might stand a bit too long here. Yeah, the remaining part is a bit faster. The newer EMath topics are you like still quite familiar with?
A bit, not really, but
Like set language all this, so
yeah.
set language matrices. Okay. Yeah, so that one because it's a regular class for EMath, so hopefully that part I think I can go a bit faster also because that one you all learn like in school I don't think you all learn it too long ago also. So should be a bit clearer. This one, I mean, she said she not very good with that, so it's a bit longer. Okay, for the benefit of time, this one I know you directly can, but okay, I'll just show you what to do for this one first, because we won't have too much time. Okay, so for part B, right, you either need to make x or y the subject first. Okay, for the linear equation, then you will sub it into the xy equals 6. Okay, so let's say I want to make x the subject. Okay, I want to make x the subject. And it's y the subject is fine also. So x the subject means I want x equals to 5 minus y. Okay, equation 1. This is equation 2. Okay. So all I need to do here is sub equation 1 into equation 2. Okay, so 5 minus y times y equals to 6. Okay, so 5y minus y squared equals to 6. Okay. Then you can solve the equation. We make it nicer first. Okay, so quadratic equation, typically what we want is the coefficient of y to be the coefficient of y squared to be 1. Okay, so minus y squared is not good, right? So we can multiply both sides by minus 1. So y squared minus 5y equals to minus 6. Okay, and we move the 6 over, y squared minus 5y plus 6 equals to 0. Okay, and this one is going to be y minus 2, y minus 3 equals to 0. So y equals to 2 or y equals to 3. Okay, so when y equals to 2, okay, let's look at this equation. X equals to 5 minus y. So when y is 2, then x is simply 5 minus 2, which is 3. And when y equals to 3, then x equals to 5 minus 3, which is 2. Okay, so my two answers are this one. Okay. X is 2, y3, and x3, y2. So the answer here, right, on the printed one, right, is if I make y a subject, the working I just did is to make x a subject. So you can see, you do it either way, you still get the final answer. Okay, as long as you make sure you don't make any mistakes. Okay, any questions? Okay, then this is the last portion. Okay, linear equations, okay, very quite simple. Okay, this last part I think is the simplest portion already. Okay, linear equation is when you have ax plus b equals to c. Okay, then how to solve this? Okay, you just want to make x a subject. Okay, if you could do the earlier question, then this one is very easy already. Okay, so 3x minus 7 equals to 11. Okay, you have to make x a subject. Okay, so you add 7 on both sides, then you divide by 3. Answer is 6. Okay, then the next one. Okay, so something like this, you can, whenever you see fraction on left side, fraction on right side, nothing else. One thing you can do is to cross multiply. Okay, which is, yeah, or you multiply both sides of the LCM. Okay, so you cross multiply, then you make x a subject. Okay, x is minus 8. Okay, very simple. Okay, this one, how is it simple? Is see, okay. For part A, you can move the 2x over, so 3x equals to minus 12, and the 4 you move it to the right side. Okay. For part B, you can cross multiply. Okay, simplify it. 9 times x minus 1 equals to 4 times 2x plus 5. Okay, then you move the x to one side, you move the number to the right side. The x is 29. Then for part C, you just use you just simplify it accordingly. Okay, just notice that for part C, right, the minus 2 and minus 1, okay, become plus 2. Okay, then you move x over to one side, you move the number to the right side, then you divide by 11. Okay, so this portion is very simple. Okay, and inequality. Okay, inequality is essentially the same thing. The only thing to take note of for inequality is when you multiply by a negative number, multiply or divide by a negative number, make sure you change the sign. Okay, if it's a less than, it becomes more than. If it's more than, it becomes less than. Okay. So on a number line also, if you want to illustrate inequality, okay, if it's like here is -2, you want to show x more than -2, you do like this. If you want more than equals to -2, then you do this. You shade the inside. Okay. Then let's say you have two inequalities. Okay, -2 and 2. Okay, so for example, so you want x less than 2 and x more than equals to -2. Okay, so -2, then like that. Okay, then let's say you want to find a region, then the region is this. Okay. In other words, it's like that. Okay. Drawing a number line. Okay. So solve 3x minus 2 less than 10 and represent a number line. Okay. Solving this, make x a subject, x less than 4. Okay, so 4, then you do like that. Okay. Then solve 5 minus 3x more than equals to 14. Okay. So here what you can do is -5 on both sides, and then you divide by -3. Okay. But because it's -3, it's negative, then you have to flip the sign. Okay. So x less than equals to -3. Okay. And this one double inequality. Okay, double inequality. What you have to do is okay. I mean the way I would usually do it, right, is to just split the two. Okay. So -4 less than equals to 3 minus 2x, and 3 minus 2x less than 9. Okay. So you can solve each of these individually, then you combine the answer at the end. Okay. The printed working, I won't really suggest doing that because it's won't be too comfortable working with it. Okay. If you feel it's okay, then that's fine as well. But I do recommend splitting into two inequalities, then you solve one by one, then you combine in the end. Okay. Yeah, so okay, the inequality, this one also due to lack of time, and because I think it's quite simple, I won't really solve it too much. Okay. Yeah, equation inequalities, okay, essentially just making x a subject. Okay, and inequality, a special thing is really just to know how to illustrate it on a number line, and also remembering to reverse the sign when you multiply by negative numbers. Okay, any questions? Okay. So here is what we went through. So linear equations, how to make x a subject, isolating x, and multiplying throughout. Okay, quadratic equations, 3 ways to solve: factorization, quadratic formula, forming a square. Simultaneous equations, we eliminate or substitute, and inequalities when we flip our sign and multiply or divide by negative. And if it's open, use open circle if it's less than or more than, and closed circle if it's less than equals to or more than equals to. Okay. Yeah. And then we move on to the next one. Okay. So this topic also, I think it's actually not too difficult. Okay. In fact, I think you all would have used it pretty recently. Okay. Just some I'll just give some reminders. Okay. This one is pretty recent Sec 4 topic, right? Okay. So set language notation, the different symbols, okay, what it means, okay, how to describe sets using words, listing, and this set builder notation, how to find a union and intercept of sets, complements and Venn diagrams to represent relationships, solve counting problems using Venn diagrams. Okay. So a set, what is a set? Okay, a set is collection of distinct object elements. So this distinct meaning it cannot have repeated stuff. Okay, so in a set A, you cannot have 1, 2, 3, 4, 1. Okay, it doesn't work. It must have distinct stuff. You cannot have repeated stuff. Okay. You can also describe it, okay, a set that has elements 1 to 5. Maybe a set that has even numbers from 1 to 10 inclusive. Okay. There's a way to describe a set as well. Okay. Then some definitions. Universal set is the set of all elements that you want to consider. Okay. So if the universal set is numbers from 1 to 100, then I have a set A which says, okay, I want even numbers. Then the even numbers must be from 1 to 100. Okay. And then empty set, okay, this symbol like a kind of like a stop sign, right? Is a set with no elements. Okay, inside is nothing inside. Okay, another way you can see it is like that. It's a curly bracket inside the nothing. Okay. So sometimes we also use this funny this curly guy as a universal set. Okay. But for now we'll use a U. Okay. Let's take note, right? Okay, this guy here, this stop sign guy is the same as this, but then if you were to write this, then this is not correct. Because that's the set containing the empty set. Okay, it sounds very weird, but like that's the case. It's not the same. Okay. And as mentioned, don't repeat elements. Okay. And you can also use a different way to describe sets. Okay. Yeah, I won't really go through that one. It's not really part of the syllabus. Okay. Okay, this is what's the most important one. To be able to translate set language the notation right into English. Okay. So the euro sign is an element of, then if there's a slash is not an element of. NA means number of elements in the set. Then the C right with the line below is a subset. And then if the C with no line is proper subset. Okay. U shape is union. Then upside down U is intersection. Then sometimes they use a prime. Okay. For A then the C on top. Sometimes they use a prime like an apostrophe. Okay. And lastly empty set. Okay. So the examples and the meanings are as follows. Okay. So if it's an element of a set means inside is a member of the set. Okay. Then NA is simply how many things are inside. Subset means every element of A is in B. Okay. Proper subset means every element of A is in B, but then A is not equal to B. Okay. If A is exactly equal to B, then A is going to be a subset of B, but not a proper subset. Okay. Then the two most important one, union and intersection. So if it's a union means it's in either A or B, or can be in both also. Intersection means it's in both. Okay, then the complement means it's in the universal set but not in A. Okay. And empty set means there's nothing inside. Okay, any questions for this? Okay, so when you're solving set questions, try and convert to English first. It helps a lot. Okay. So simple example, okay. State whether 6 is element of A. Okay, so clearly 6 is inside the. Okay, so yes, it does contain. State whether 4 is element of B. Okay, so B is 2, 3, 5, 7. So 4, B does not contain 4. Okay. Then state whether A is a subset of the universal set. Okay. So that means every element of A must belong to the universal set. Okay. I mean that's always going to be true. Okay. It's not possible to have a set that has things that is not in the universal set. Okay. But anyway, you can check. 2 is inside the universal set, 4 inside, 6 inside, 8 inside. Okay, so 8. A is a subset of U. Okay. Yeah, then we can look at this one real quick. Okay, so this one, let's give it like a minute to solve a minute. Simple. So like one line, yes or no, and the reason. Okay, so the only real like tricky thing is maybe part C. But for part A, okay, clearly Q contains 1, 3, 5, 7, 9 doesn't contain 8, so that's false. Okay. State whether Q is a subset of U. Okay, and every element of Q belongs to U, so yes, it's a subset. Okay, then state whether empty set is subset of P. Okay, so this one you don't really like it's a fact that is true, but I don't think you'll get tested. But the empty set will be a subset of every set. Okay. Every single set, the empty set will be subset of, so yes, that will be true. Okay. Then we move on. Okay, now we talk about union and intersection. Okay. So union, as mentioned, right? Union is kind of like the English word or. It belongs to A or B. Okay, intersection means A and B, both A and B. Okay. So if we have A equals to 1, 2, 3, 6, and B is 2, 4, 6, 8, then the union is any element that is either in A or B. Okay. And A intersect B means elements that is in both A and B. Okay. Okay, this one is the most important thing to understand. Okay, any question about this? Okay, then you can try this example. So this is an example of where earlier all the sets we listed out like 1, 2, 3, 4, 5. Okay, this one in this example here you use words to describe it. That's another way to do it as well. Okay. So just to know, right? Okay, universal set. Okay, the universal set is basically the big picture. Then M and N are both inside it. So if the universal set says I want numbers from 0 to 30, then M says X is a perfect cube, right? Means X must be between 0 and 30 also. Okay. Yeah, give this question a try. Okay. The first step is really to write down what M and N are. This one I think about 2 minutes. Okay, you all are attending the next 2 modules, right? I might consider moving like the last part to like one of the next module because I don't know if I have enough time to complete without like super rushing through the last part. Okay, we'll see how it goes. Okay, we've got 30 more seconds. Okay, so it's okay if we have a break now because I think I spent a bit too long on some of the earlier parts. Okay. Yeah, then we'll just after we'll just continue to the end of the lesson. Okay, so let's look at this one. Okay, so our restriction for universal set is from 0 to 30, from excluding 0 but including 30. Okay. So M says X is a perfect cube and then N is X odd. Okay. So X is for M, right, basically is a perfect cube that is between 1 and 30. Yeah, 1 and 30, including 1 and 30. Okay. So perfect cubes, okay, what are the perfect cubes? Okay, 1, then 8, then 27. Okay, then anything after that then is out of 30 already, not within 1 and 30 already. So this means M is equals to 1, 8, 27. Okay, M is 1, 8, 27. It's a perfect cube between 1 and 30. Okay, then what about N? N says X is odd. Okay, X is odd and then also is between 1 and 30. Okay, so you don't need to write down every single thing, but it's going to be 1, 3, 5, 7, 9 all the way until 29. Okay, then you have to find M intersect N. Okay, M intersect N means it's you want the elements that lie in both M and N. Okay, so you have M and N already, then clearly okay, we want essentially what we want, right, is we want perfect cubes that are odd. Okay, the intersection says N, right? So we want a perfect cube and we want it to be odd. Okay, which means it is 1 and 27. Those are perfect cubes that are odd. So M intersect N is 1 and 27. Okay. So yeah, this is how you maybe read it in English also. Like the intersection sign is N, then if it's union is all. Okay. Okay, the next one, okay, complement. Oh, I need some big space. Okay. So complement of A, written then the C on top, right? It means when it's in a universal set, but it's not inside A. Okay. It's elements that are in U but not in A. Okay. Sometimes, as mentioned, sometimes you use a prime, okay, like a little apostrophe to denote the complement. Okay. So example, okay, let U be 1 all the way to 10 and A to be 2, 4, 6, 8, 10. Okay. So if we want to find A complement, then it's elements of the universal set that is not inside A. Okay, everything outside of A. So in this case, it'll be 1, 3, 5, 7, 9. Okay, the numbers that are not inside A. Okay. Yeah, okay, this is not too difficult a concept to understand. Okay. Try this question, and then this one shouldn't take too long. Okay. Okay, so for part A here, this is the elements of A. Okay, so H must be a multiple of 3 that is between 1 and 12. Okay, so 3, 6, 9, 12. Okay, A will be 3, 6, 9, 12. Okay, then find A complement. So A complement is any number that is outside of A that's in the universal set. So it's 1, 2, 1, 2, 4, 5, 7, 8, 10, 11. Okay, then find number of elements. Okay, N A complement is how many inside. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So 8 numbers inside over there. Number of elements A complement is 8. Okay, so I think this is also quite simple. Okay, then Venn diagrams is what you use to illustrate this sets. Okay. Usually the rectangle you use for universal set, then all these events A all this are inside. Okay. The circles is how many sets you have. Okay. Uh, you will work with 2 sets, 3 sets, then it's possible to be tested, but quite rarely. Okay. And you can apply the same principles to solve 3-set questions. Okay. So in a Venn diagram with sets A and B inside the universal set, you shape this region B intersect A complement. Okay. So when you see this, right, always try and read it in terms of like English. Okay. B intersect A complement means B intersect A complement means it's in B, then the intersect means N. The A complement means not in A. So it's in B and not inside A. So you shape this particular region here. Okay, try and the intermediate step is always convert to English, so then you I think it's better to understand it. Okay, then can give this question a try. Okay, some of it is not super easy. Okay, uh, okay, and in general, when you construct these kind of expressions, right, don't do some crazy stuff like A union B complement intersect A complement. This kind of thing. Don't for at least for these questions, right, you can leave it in like a union B complement type thing. I don't here they are not the questions are not too crazy. Okay, you can write it in like 3 letters. Okay, the first letter, then complement or whatever, then intersect or union, then the second letter. Okay, 30 more seconds. For this kind of questions, usually the answer, there's more than one answer. Usually there's one answer. Okay, for the simple ones, then actually there's usually one answer only, but for the more complicated ones, then it might more than one answer. Okay, so okay, I will go through this one now. Okay, for part one, okay, it's just the portion divides in A and B, so just put A intersect B. Okay, divides in A and B, so A intersect B. Okay, for part B, okay, it lies in A but not in B. Okay, so here will be A intersect B complement. Okay, because it lies out, it is everything in A that is not in B. Okay. Then for part C, okay, for part C, notice it's basically everything in A. Sorry, it's everything. It's actually the opposite of this. Right? It's actually the opposite of part B. Okay, so actually, what you can do, okay, a smart way to do things is like that. Then you complement the whole thing. You see, that works also because it's like it's like you flip the colors for part B. Okay, but another way to notice, like actually this thing here, right? You want the whole of B. Okay, you want the whole of B, then you can actually union it with A complement because everything outside of A. Okay, so if you have B already, right, is this guy. Then A complement is uh everything else, right? Okay. But then if you choose B already, then this guy is already here. So B union A complement works as well. Okay. Then lastly, okay, for part D, okay, this one has two answers. Okay, it's everything except A and B. Okay, and that little center region here is A union B, right? So one way you can do is A union B complement. Another way is A complement intersect B complement. Okay, so here are some answers to consider. Okay, okay, the triple Venn diagram I will skip because it's too troublesome. Okay, usually don't do with triple, but for triple Venn diagram, if you're asked to ever do it, right, it's like this treat as like English. Okay. Um. Okay. Then lastly, okay, we have counting. And the last portion of this. Okay. Counting with Venn diagrams. Okay. So okay, how does this work? Okay. Okay. So how does this formula work? Okay, let me draw a simple Venn diagram. Okay, so imagine you have two guys. Okay, so the union, right? The union is like this, right? Okay, it's basically you shape both of these guys. Okay, what if I want to express the union in terms of if I have A, okay, A is this guy, okay, A is this, the left one, and B is the right one. Okay, if I have if I have A and I have B, maybe the number of elements is like I have number of elements of A, number of elements of B, and I have number of elements of the intersection point. Then how do I write it in terms of the union? Okay, so this formula here actually gives us a way to write in terms of the A, B, and then the union and the intersection. Okay, so how does this work? Okay, so the union is as I mentioned is this whole guy, right? Okay, so A is this guy here, and B is this. Okay, if I add them together, right? Actually, you don't notice that the middle part gets repeated two times, right? Because A already counts the middle part, then B counts it again. Okay, so if I only want to get this guy one time, I have to subtract the middle part, right? Because the middle part is counted two times. Okay, so that's actually what I'm doing here. If I want the union, okay, the union is essentially this whole guy, this whole green guy. Okay, I can add A and add B together. Then I subtract the middle part because the middle part is counted two times. Okay, any confusion on that? Okay, so this is used in here. Okay, so in context of the question, in a class, 22 students take physics, okay, 18 take chemistry, and 10 students take both. Find the Okay, N of A union B means how many students take either of them. A union means either physics or chemistry. Okay, then you can just apply this formula. Add physics, add chemistry, then you minus the people who take both. So there will be 30 students who take at least one of them. Okay. Yeah, then this example here is actually the same thing. I will solve it real quick. Okay. 2 minutes. Okay, so here this one is actually the formula. Okay. So 22 take physics, 18 take chemistry, and 10 take both. Okay, then how many people take either one? So you add them up, 22 plus 18, 40, then minus 10, so 30. Okay. Then find the number of people who take neither physics or chemistry. Okay. So this one is not is a bit more dot, but okay. Really you're just trying to find the total number minus the union. You can kind of treat it as a Venn diagram, right? So your Venn diagram, right? You have this region here, then you want to take total the universal set minus the center. Okay, so it's 10 people. Okay, any questions? Okay, yeah, so just a quick summary of what we just did. Okay. Um what a set is, what it means to be a member, then the universal set, and then some notation about subsets, empty set, universal set, okay, union, intersect, okay, and most importantly, how to treat it like an English statement and how to interpret in a Venn diagram and shading. Yeah, and then the last formula that we just mentioned, the okay, I only mention the name because it's more confusing, but this particular formula when you use to count how many how to relate each of the number of elements in A and B with the intersection and the union. Okay, then next we move on to matrices. Okay, yeah, I don't really think I will have too much time because afterwards it's still the angle triangle, then the angles, triangles, and polygons. Then afterwards there is still similarity and congruence. So I think at the very least, the last chapter, the similarity and congruence, will have to be shifted to the next module. Okay, the first part of the next module will just be that, I guess. Yeah. Okay. So matrices, okay, display and interpret information in the matrix of any order. Okay, the order is the size of the matrix. Okay, then perform matrix addition, subtraction, and scalar multiplication. How to identify when you can multiply matrices? Determine what is the size of the output matrix and compute each of the entries properly. Okay, and how to use a matrix to modify a real life situation. Okay, this you see the O level DYS all this, right? Then it will be the same thing, right? You're just using it to model some kind of like this guy is buying some certain object, okay, and how much is the cost of it. Okay, so what is a matrix? Okay, it's just a rectangular arrangement of numbers with rows and columns. Then if you have m rows and n columns, you describe it by what is called an order, m times n, m by n. Okay, yeah, it's order m by n. Okay, so a simple example. Okay, this one is 2 rows and 3 columns. So row is horizontal, column is vertical. So 2 rows, 3 columns. And order of A is simply 2 by 3 or 2 times 3. Okay. Then if I have to state the entry in row 2, column 3, okay, row 2, column 3 will be row 2, column 3, so 7. Okay, simple enough. Okay, this one also very, I won't really bother going through this one. Okay, Okay, so the rows here represent the day. So Monday, Tuesday, okay, Monday, Tuesday, and the columns represent sandwiches, drinks, and fruits. Okay. So how many drinks were sold on Tuesday? Okay, so essentially you want to find that. Okay, Tuesday is here, then drinks is here. So this one 35. Okay, so 35 drinks were sold on Tuesday. Okay. B, how many items were sold on Monday in total? Okay, so Monday in total means 25 plus 40 plus 18. Okay, that's going to be 83. Okay. Okay, then addition and subtraction. Okay, this one is the simple stuff, right? You can just add element wise. Okay. Make sure once again, right? Ensure you account for the negative sign. Okay, minus or minus for the plus. Okay. So each element just match it. Okay. And the matrices must have the same order. Okay. If they don't have the same order, then you cannot go and add it or subtract it. Okay. Addition, then multiplication, then maybe can we see about it later. Okay. So scalar multiplication, okay, one is the same thing. Basically you just multiply the number in front, right? You multiply to each of the entries of the matrix. Okay. So k times a, then each element inside will multiply by k. Okay, then you can give this one a try. Okay, 2a minus 3b. Yeah, you can do it in 2 steps. If you want to do it in 1 step. Okay. I would recommend doing two. Okay. So here, okay, do it in 2 steps. Okay. So 2a will be 1 8 minus 4 6, and 3b will be 15 minus 3 18 0. Okay, so 2a minus 3b. Okay, one more thing, when you write down matrices or vectors, write down when you're writing it down, you use the tilde to denote that it's a matrix, okay, or vector. Okay, so 1 8 minus 4 6 minus 15 minus 3 18 0. So minus 14 11 minus 22 and 6. Okay, this should be the answer. Wait, yeah, I'm doing very well. Uh, this should be two. Yeah, it's minus 13. Minus 13, 11, minus 22, 6. Okay. Okay, this one's too simple. Okay, so matrix multiplication is what most people struggle with. Matrix multiplication. So matrix multiplication, right, is only defined in a very specific situation. Okay, is when the number of columns of the first matrix is equal to the number of rows of the second matrix. Okay, so m by n and n times r, then you can go and define matrix multiplication. Okay, and the product will be the row of the first matrix and the column of the second matrix. Okay, basically if a middle number matches, then you can define it. Okay, so for 4.2.3, you can give this a try. Okay, this one shouldn't take too long also. Just check whether you can even matrix multiply, and then check whether I'll just state the order. Okay, the order of the product will be the rows of the first matrix by the second column of the column of the second matrix. Okay, let's take note, you're not asked to compute the matrix, so just check whether you can do so. The computation is afterwards. Okay. Okay, so here I'll just go through whether you can compute whether the product. Okay, so the first matrix is going to be 2 by 3. This is a 3 by 2, and then this is a 2 by 2. Okay, so AB will be a 2 by 3 and a 3 by 2. Okay, so the middle number matches. So yes, you can compute it. And the order of the product will be 2 by 2. Okay, 2 by 2. Okay, whether you can even do it, it's going to be 3 and 3. Okay, so good. Then the order of the product will be 2 by 2. Okay, then BA, okay, B is 3 by 2 and A is 2 by 3. Okay, so once again, the middle number matches, so this one you can do it, and the output will be 3 by 3. Okay, AC. Okay, so the middle number here does not match, so you cannot do this. If you cannot do it, then there's no order of product. Okay, then BC, B is 3 by 2 and C is 2 by 2. So number matches good. And the output will be 3 by 2. Okay. So always check whether you can. Okay, in the exam you won't be given something you cannot matrix multiply anyway, but it's still good to check. Okay, just to verify. Okay, then next we look at how can we even compute a matrix product. Okay, so the matrix product must be it must be in this condition where the number of columns of the first matrix equals the number of rows of the second matrix. Okay, you must satisfy that condition first. Okay, then if you can, once you do that, then you can multiply. Okay, so if you have a matrix C, which is the product of A and B, then each entry of the matrix C, right, is essentially row I times column G. Okay, so if it's the first if it's the first row, first column, then it's the first row of matrix A times first row of column or first column of matrix B. Okay, so we can look at this example here. Okay, this example here. Always check whether you can even matrix multiply first. Okay, so you can do that. Then you can take a look at each of the entries, how to compute it. Right? It's row 1. Okay. For the first entry, C11, I'll go through the first one only. Okay. 2 times 1. Okay, then minus 1 times minus 3 and 3 times 4, okay, which is row 1 of matrix A multiplied by column 1 of matrix B. Okay, then the other ones are okay, so C12 means row 1 of matrix A times column 2 of matrix B. Okay. Yeah, then apply it for the rest. Okay. Any questions? How to do it? How to use it? Okay. Okay, so the little thing here, okay, is I mean I can't really see the answer, but like is matrix multiplication commutative? Is AB equal to BA generally? Okay, it's not okay. Sometimes if you can even multiply AB and BA, then it might be the sometimes it could be the same. Okay, but sometimes if AB can exist, then BA cannot exist. Okay? Yeah. So sometimes AB can exist, but BA cannot exist. So that's another way to think about it. Okay. Yeah, then you can find this one you can find AD. AD is let's just find AD, you don't need to find BA. You just verify whether you don't know how to matrix multiply properly. Okay. And like the way to check on whether you can even do so. Okay, both are 2 by 2, so definitely you can. Okay, then what do you notice? You see, like it's really just to check whether they're equivalent or not. Okay. I don't think they are. Okay, so let's calculate AD. AD is this AD equals to 5, 6, 7, 8, 1, 2, 3, 4. Okay, so the output here will be 2 by 2. Okay. So the first entry is row one of matrix. The first matrix multiplied by column one of the second matrix. So 5 times 1 plus 6 times 3. Okay. Thereafter, the next entry is row 1 of the first matrix times column 2. So it's 5 times 2 plus 6 times 4. Okay. Then afterwards, the row 2 of the first matrix times column 1 of the second matrix. So 7 times 1 plus 8 times 3. Okay. Then lastly, we have row 2 of first matrix multiplied by column 2 of the second matrix. So 7 times 2 plus 8 times 4. Okay. It should be 23, 34, 31, 46. Okay. Then DA, if you calculate it, it will be this and it will be different. Okay. Only the DA and AD are not the same. Okay. So this proves the previous points. Okay, any questions? Okay. Matrix product is one of the easiest ways to make mistakes. So make sure to do it carefully. Okay. Okay, then what is the use of matrices? Okay, as mentioned, the real use of matrices is to really model real life situations. Okay, usually money inequalities and stuff. Okay, so example here, a shop makes 2 snack bags. Bag 1 uses 3 units of sugar, 2 units of flour, and 1 unit of chocolate. And bag 2 uses 1 unit of sugar, 4 units of flour, and 2 units of chocolate. And the cost per unit is as follows. Okay, 30 cents for sugar, 40 cents for flour, and 120 for chocolate. Represent the quantities as a matrix Q and find QP and explain what it means. Okay, so Q is the quantity matrix. Okay, so in the exams, actually, they will tell you the size of the matrix. So you don't have to figure out whether it's 2 by 3, 3 by 2, or whatever. Right? Okay, so the quantity matrix, okay, essentially, you're just going to model this data that's given here. Okay, let's kind of convert this into a matrix. Okay, then P is as given the price. Okay. Then you multiply Q and P. Okay, you kind of understand what it does. Right. 3 is the pack A units of sugar multiplied by 30 cents. Then afterwards you have 2 times 0.40, which is pack A's unit of flour times the unit cost. So you can expect the answer, right, will probably be something like pack A's total cost for one unit. No, the cost to make one pack A, one pack one, and then the cost to make one pack two, something like that. Okay, multiply. So the first entry, then after as expected, right? This answer here is the cost for one pack one, and then the second entry is the cost for one pack two. Okay, and how to be able to tell what these values mean, right? So as I mentioned in previous classes, like that, you just have to look at what each of these things mean. Okay. So don't look at the final value here. Don't look at the final value. You look at what makes up the final value. Okay. So if we were to look at this, 3 times 30 cents plus 2 times 40 cents plus 1 times 120. Okay. You will see that, okay, as mentioned, right, is 3 units of sugar times 30 cents means pack one's cost for sugar. Then 2 times 40 cents is pack one's cost for the flour. And then lastly, 1 times 120, which is pack one's cost for the chocolate. Okay. So if you can look at it this way, then you will easily see, okay, that's the cost to make one pack one. Okay, that's simple enough. Okay. Yeah. Okay, this one also I'm going to go through, spend too much time going through this one. Okay, let's short answer. Okay. I mean, this matrix multiplication is very easy. In the exams, usually they'll give you like a 2 by 3 or something like that to multiply. Okay. So short A is 213 and short B is 121, and then the unit prices are as such. Okay. Part A, find AP and interpret it. Okay, AP is 1 by 3 and P is 3 by 1. So AP is 1 by 1. Okay. If it's a 1 by 1, okay, you don't really need to write. Technically, you do need to write bracket. But I guess if you omit it, it's fine. Okay. So AP will be equals to 950. Okay. And quite obviously, this one is very easy to see, right? AP is 2 times 150 plus 1 times 320 plus 3 times 110. Basically, it's the amount of money that the student bought from shop A. The amount of money student spent in shop A. Okay. And BP you can kind of think of it as the same, right? It's the amount of money a student spent in shop B. Okay, then part C, total amount spent across both shops, just add the two answers together. Okay. So interpretation, shop A spending 950. Then for part B, the amount is $9. Okay, so interpretation is he spent $9 in shop B. So total is 1850. Okay. Yeah. I think okay, this question the fundamentals here are quite simple. It's just that the calculation can get a bit confusing, especially if the matrices are quite big. Okay, in the exam usually is nothing more than you want like 4 rows, 4 columns. Maybe like usually three. Three is the maximum for rows column. Maybe like 2 by 3, 3 by 2. Okay. Okay, any question for this topic? Okay. Yeah, so quick cheat sheet. Okay, order and how many rows, how many columns. Then adding and subtracting only do it if they are the same size. Okay, then the basically the scalar multiplication you can just basically apply to each value. Okay. Addition and subtraction you do it entry wise also. So the first row, first column you add with the first row, first column of the next matrix. Okay. Multiplication, the troublesome one is to really check which two matrices can even be multiplied. The column of the first matrix must be the row of the second. Then the output size is the row of the first matrix and the column of the second matrix. Okay. Yeah, then the entry on the ith row and the jth column is calculated by the row I of the first matrix multiplied by column J of the second matrix. Okay. That's the technical way to do it. But then I think for your level, I think if you all just do it enough, then you can see the pattern, like how it's formed. Okay. For the rule itself is more technical. Okay. Yeah, the common tracks nothing to talk about too much. Okay. And yeah, the question, the modeling is really like basically 99% of matrix questions, they won't ask you to calculate something and call your data. Okay. They'll ask you to calculate and model using a real situation. They'll give you like a real situation, they ask you to construct a matrix and then do some matrix multiplication, interpret the data. Okay, then that's how it usually works. Okay, then now we move on to this angle, triangles, and polygons. Yeah, so yeah, okay, this one thing it's gonna be fairly big, okay. Quite a few things, okay, but I think we have about like 20 minutes. I think we can actually cover everything. Okay. Of course, not in super great detail. That one is possible anyway. Okay. So first objective, apply angle properties. Angles on the line and a point and vertically opposite. Okay. Angle properties of parallel lines, corresponding alternate and co-interior not too commonly used. Okay. Then properties of triangles, angle sum, exterior angles, and isosceles. Okay. Exterior angle is also one of the things you don't really need to use too much if you can use other properties. And lastly, find interior and exterior angles and polygons. The exterior angle once again is I don't really see it being asked too much. Okay. Mostly people talk about interior angles. Okay. So the basic angle properties you all should be very familiar with. Right? Angles of a straight line is 180 degrees. Angles at a point, okay, around the whole point is 360 degrees. And vertically opposite angles are equal. So vertically opposite angles, something like this, right? Draw like this, then this guy is equal to this guy. Okay, vertically opposite angles. Okay, so like you can identify from X shape. Okay, so simple example. Three angles on the straight line are 2x plus 10 degrees, x degrees, and 50 degrees. Find x. Okay, so you're using the angles on the straight line, sum of angles on the straight line is 180 degrees. Then you add this 3, it'll be 180. Then it's just an algebraic equation. Okay, one of the chapters we did just now. So x is 40. Okay. Then two lines intersect. One angle formed is 30 degrees. Find all 4 angles. Okay. In exams, usually they will accompany the picture. They don't really just say something like this. But even if they don't, you should know that how you may want to solve it. Okay. So if the two lines intersect and one angle form is 38 degrees, then there is a vertically opposite guy, which is 38 degrees as well. Okay. Then if this guy is 38, if this guy is 38 degrees, 38 degrees, then one way to solve it, one way to solve it is to use angle in a straight line, angles on a straight line. So this is a straight line, and if this is 38 degrees, then this guy is whatever makes it 180 degrees, so 142 degrees. Okay, and this guy also will be 142. Okay. Another way you could do it, right, is to notice that these two guys are actually the same angle. Then you can just take 360 degrees, which is angles at a point, minus 38 degrees, minus 38 degrees, divide by 2. Because they're the same angle, right? So you minus this guy, then you divide by 2, you get one of these guys. Okay, that's one other way to do it. Okay, so this kind of angle questions also is not really like set in stone what method you should use. It's more of how you want to approach it. Okay, but usually there is the best way to do it. Okay, usually there is a fast like it's a way that is a bit faster than the others. Usually. Okay. You can do part A or the okay, part A and C, A and C. Good. About 2 minutes. Okay. For part A, 3 lines meet at a point. Two of the angles form 73 and 115. Find the third angle. Okay, so simply angles at a point, right? So the third angle will just be 360 degrees minus 73 degrees minus 115 degrees. Okay, that will be 172. Okay. For these questions, okay, later on once you start doing those harder questions, right? You should write a reason also. This one technically you should write a reason, but yeah, I'll just let time write it. You should write angles at a point, some angles at a point. Okay. Then for part C, angles on the line are theta, 2 theta, and 3 theta. So this one is angles on a straight line. The sum is 180 degrees. So theta plus 2 theta plus 3 theta is 6 theta, which is equal to 360. So theta is 60 degrees. No, not 360, 180. So theta is 30 degrees. Okay. Then now we look at parallel lines. Okay, parallel lines. Corresponding angles. Okay, so it's an image here. Corresponding angles is like this. So this guy will be equal to this if these two are parallel. Okay. Then alternate angles. Alternate angles is okay, I'll draw a separate diagram. It's when you have these two lines, okay, the Z shape, okay. If the top and the bottom line are parallel, then this guy is equal to this. Okay. The co-interior, okay, this one, it's typically is like this kind of diagram. Okay, then this guy and this guy. Okay, so these two blue angles there, these two blue angles, maybe I call it alpha and beta. I mean, alpha plus beta is equals to 180 degrees. Okay, this one is interior angles. Okay, so this one is alternate. This is corresponding, and this one is interior angles. Okay. So these are the three properties that have to do with straight parallel lines. Okay. Just try and find this kind of shapes if they ask to solve questions that you potentially suspect. Then to have these properties. Okay. Of course the lines must be parallel. So if the question doesn't say they are parallel, right, then don't assume it. Okay. Even if they look very close to parallel, then you shouldn't assume it. Okay. Okay, so once again, right, here they're not pictures. You should still be able to solve out pictures, but usually pictures, yeah, the pictures will go a long way. Okay. Okay, so essentially what this question says, AB is parallel to CD. Okay, so it's AB, CD. Okay, then this is 65 degrees, and then this is 3x plus 5 degrees. Okay, so because of alternate angles, then we can say that they're equal. Then we solve for x is 20. Okay, and then this guy, okay, essentially what's happening here is this is 4y minus 10 degrees, and this is 2y plus 10 degrees. Okay, and this one we use interior angles, right? So they will sum to 180 degrees. They are so-called supplementary. Okay. Then once we find y already, right, then we can find each of the individual angles. So by using the fact that they are supplementary, we find that y is 30. Okay. Then 4y minus 10 is going to be 110, and 2y plus 10 is going to be 70. And of course, 70 plus 110 is 180. Okay. Okay, then yeah, I think we'll skip this parallel lines one. Okay. Properties of triangles. Okay. Angle, okay, the most basic one. Okay. Angles will sum to 180 degrees. Okay, I definitely think we don't have enough time for the last one. Probably okay. Okay, just a brief run through. Okay, then you all can take a look at it. It's the last chapter, maybe even this chapter, the last chapter, then you see if the next module we could maybe spend a bit of time going through that. Okay. So the first one, angles will sum to 180 degrees. Okay. Then an exterior angle of a triangle equals the sum of the two non-adjacent interior angles. Okay, so what does that mean? Okay, this one I think maybe you're not too familiar with it. Okay. So let's say this angle here. This angle here, right, will be the sum of these two guys. Okay. So this A is B, this is C. Okay, so C will be equal to A plus B. Okay. Yeah. But as I mentioned, right, you don't really need to use this or memorize this specifically. You can still solve the question without using this. Okay. Next one, isosceles triangle. So isosceles triangle means there are two sides. Okay, two sides are the same. So usually they will use a little dash to denote that the two sides are the same length. Okay. If the two sides are the same length, means these two angles are the same. Okay, the top guy is not the same, of course. And equilateral triangle is when all sides are the same. Okay. Then each of these angles here is 60 degrees. Okay. And then of course right angle triangle, you all know what that means already, right? 90 degrees. Okay. And right angle triangle, okay, like this one is jumping ahead to like some of the later chapter, next module, the Pythagoras theorem, trigo, right? Okay. Right angle triangle means you can use Pythagoras theorem, you can use the trigo ratios to solve it. Okay. Okay, example, okay, in triangle ABC, angle A is 52 degrees and angle B is 73 degrees. Find angle C. Okay. So what this means, right? This kind of notation, okay, usually you see like angle ABC, angle ABD and stuff, right? Okay. What this means is if I draw a triangle like this, okay, I just anyhow draw, I don't know the shape of it. So angle A means this angle has 52 degrees, angle B is 73. Okay. Then of course angle C is just going to be 180 minus 52 minus 73 is 55. Okay, 55 degrees. Find the exterior angle at C. Okay, exterior angle at C will be this red color guy. Okay, and this red color guy will be the sum of the two angles that are not touching it. Okay, so the angle that's touching it is this fellow here. Okay, then the other two guys that are touching it is 52 and 73. So the exterior angle is 52 plus 73. Okay, or in other words, okay, like you notice I don't actually have to use that to solve this because what can I do? I want to find this red guy, right? I have this at 55 degrees. I found it for part A, right? Then I can just use angles in a straight line to say 180 degrees minus 55, which is 125 degrees. Okay, that works also, right? Okay, so you don't have to use this exterior angle equals the sum of two interior angles. Okay, but if you want to use it, no one's stopping. Okay. Okay, next example, triangle PQR is isosceles with PQ equals to PR and QPR is 40 degrees. Find PQR, angle PQR. So Okay, PQ equals to PR, so like that. Then QPR is 40 degrees. Okay, so if this 40 degrees means the other two angles are the same, right? We know it's base angles for isosceles triangle are the same. So if you calculate, this will be 70 degrees, 70 degrees. Okay, 180 degrees, which is the sum of angles in a triangle, minus 40 degrees. Then because it's an isosceles triangle, the two angles are the same, then divide by 2, so 70 degrees. Okay, let's see. Okay, you can try this question. Maybe you are about 2 minutes. It's on 3 yeah, 3 minutes. 2, okay. A and B, A and B. Draw it. If you need a help with the diagram, I can draw it now. Yeah, I drew 2 diagrams, one for part A, one for part B. If you need it. It's not too difficult to interpret. Okay, so in a triangle, for part A, in triangle XYZ, angle X is, okay, let me just call angle X, let's call it A, let's call it A, okay, A degrees. Okay, then angle X equals to, okay, maybe I call angle Y A degrees. Okay, angle Y I call A degrees. Because angle X is 2 times of angle Y, so it's 2A degrees. Okay, and angle Z is 30 degrees. Find angle X and angle Y. Okay, so we can use the angle sum of triangle, right? So 2A plus A plus 30 equals to 180. Okay, so then 3A plus 30 equals to 180, which means that 3A is 150, which means A is 50. Okay, so angle X is 2A, right? So angle X is equals to 100 degrees and angle Y will be 50 degrees. Okay, then it's the exterior angle of a triangle is 110 degrees. So let me I just label 110 degrees here. And one of the non-adjacent interior angles is 65 degrees. So one of them, maybe the top one, let's say 65 degrees. Find the other. Okay. So here quite easy, right? You can use angles in a straight line to find that this is 70 degrees. Okay. Then lastly, this fellow here is 180 minus 70 minus 65, which is I think 45 degrees. No, 55. Yeah, 55. No, 45, 45. Okay, any questions for this one? Okay, then we will quickly wrap up. Okay, polygon. Okay, so polygon. Okay, polygon. Sum of interior angles. Okay, so okay. Actually, a triangle is a polygon. A rectangle is a polygon. A rhombus is a polygon. The polygon just means it's a shape with n sides. Okay, doesn't really matter how many sides there are. It's just a shape with sides. Okay, it doesn't have to be regular. Also, each side can be different in size. Okay, so sum of interior angles, meaning the angles inside the polygon, the sum of it is n minus 2 times 180 degrees, and n is how many sides there are. Okay, sum of exterior angles will be 360 degrees. Okay, exterior angles, yeah, as mentioned, it doesn't really come up too much, but it's also useful to know. Okay, so for a regular polygon, means each side has the same size. Okay, the angle is the same for each interior angle. Okay, so for a regular polygon, essentially what you're doing, right, is the sum of interior angles is n minus 2 times 180 degrees. So each interior angle is depth divided by how many sides there are. Okay, so n minus 2 times 180 degrees divided by n, and then each exterior angle is the total exterior angle 360 degrees divided by n. Okay, and your interior exterior of course will be 180 degrees. Okay, by the angles, sum of angles on a straight line. Okay. So for part A, this example here, find the sum of interior angles of a heptagon which has 7 sides. So using the formula n minus 2 times 180 degrees is 900 degrees. Okay. Then part B, find the interior and exterior angles of a regular octagon. So octagon is n equals to 8 sides. Okay. So using the formula above, exterior angle is going to be 360 degrees minus divided by 8, because 8 sides, 45 degrees. And interior angle is going to be 180 minus exterior, which is 180 minus 45, 135 degrees. Okay. And lastly, how many sides does a regular polygon have if each exterior angle is 24 degrees? Okay, so 360 degrees over n will be 24. Okay, using this formula over here, 360 over n will be equals to 24 degrees. Okay, so our goal here is to solve for n, and n is 15. Okay. Then the next example, 5 interior angles of a hexagon are 100. Okay, they give you all the angles. Find the 6th angle. Okay, so our goal first is to find the total sum of angles in a hexagon. Okay, use the first formula, sum of interior angles. So hexagon has 6 sides. Okay, so 6 minus 2 times 180 degrees is 720 degrees. Okay, then we have 5 of the angles. We can just take the total number of angles minus the sum of all the angles is 120 degrees. Okay, so these are still quite simple, I think. Okay. Okay, then this one, yeah, of course we don't have time to go I don't have time for you to attempt this, but let's go through quickly. Okay, then after this we can end the lesson. Then yeah, next lesson we will carry forward the congruence similarity. Okay. So the sum of interior angles of a polygon is 1980 degrees. How many sides are there? Okay, so the formula is n minus 2 times 180 degrees. Okay, so n minus 2 times 180 degrees, okay, equals to 1980 degrees. Okay, this is what we want to solve. Okay, you want to find n for part A. So the sum of interior angles is n minus 2 times 180 degrees. So we can solve the equation. Okay, divide 180 on both sides. You'll see that n is equal to 13. Okay. Then part B, each interior angle of a regular polygon is 156 degrees. Find the number of sides. Okay. So that's why you can solve in multiple ways also. Here they chose to use the fact that the exterior angle sum will always be 360 degrees. Okay. So if you have an interior angle being 156 degrees, then you can find the exterior angle. The exterior angle, the number of sides is 360 degrees minus the exterior angle. Okay. Alternatively, what you can do here, okay, just a suggestion. Okay. They give you the size of each interior angle, and it's a regular polygon. So another way to do it is like this: n minus 2 times 180 degrees over n equals to 156 degrees. Okay. So this works because this formula here tells you the size of one interior angle in a polygon, in a regular polygon. And this is the size that is given 156 degrees. Okay. So this is yet another way to do it. Okay. Both will give you the same answer. Okay. For part C, okay, part C is identical to the previous one. So pentagon is 5 sides. Okay. So your goal is yeah, 5 sides. Right? So your goal is to find the total number of the sum of the total angles, then you minus the rest. Okay. So you have 5 sides. Okay, then you but this one is exterior. Okay, this is exterior angle. Sorry, it's a bit different because exterior angle. Exterior angle, the sum will be 360 degrees. So you subtract all of these other ones and you get 70 degrees. Okay, this one is the trick. Usually it's just for interior, that's not exterior. Okay. And lastly, find the size of each interior angle in a regular nonagon, 9 sides. Okay. So in this equation here, you just sub in n equals to 9. Okay, and you get answer 140 degrees. Okay, any last question for this? Okay, just what we've done. Okay, yeah, okay, so some of the topics here I understand. Okay. I think I mostly skip through the things that I think are mostly understandable. Okay. Hopefully the other things were covered at least listen that page. Yeah, so as per usual, let me know if you have any questions about this. Okay. I'll upload this together with recording after lesson today. Okay. Yeah, and for module 3, okay, your okay, I'll remind you to bring this one along so we can have a look at Congruence Similarity. Okay. Yeah, maybe you can read up about this also. So because module 3 there will be this other student joining that I don't want like if you can have at least an understanding for this one already, then I think I spend less time on this better than we focus on what's actual content. Okay. Yeah, then if no questions, then yeah, I will see you for module 3. I think like next. Thank you. All right. See you. Bye bye. Bye. See you.